So a complex fraction is what these are called. It's basically when you have a fraction over a fraction. So if you notice these problems right here, you've got a lot going on. You have a fraction in the numerator and a fraction in the denominator. And they look a lot scarier than they actually are, because the whole goal of a complex fraction is just to get rid of both fractions completely. So you basically want to go from having two fractions to having one. So we're going to what we call creatively multiply by 1, and we're going to essentially find the least common multiple like we did in the beginning of this section, and we're going to multiply away the two bottom denominators. So we want to get rid of this denominator and we want to get rid of these, just by what we call creatively multiplying by 1. So the denominators that I have highlighted, what would be the least common multiple of those? Remember, you combine and then you only count the repeats one time. So what would the least common multiple be here? X plus 4. So I've got x plus 4, and then I've got x plus 4. So would you agree with me that this is technically equal to 1, the fraction that I have written on the board? Because if they could all cancel out, they would essentially become 1. So I'm not doing anything wrong by multiplying both the top and the bottom by x plus 4. So when I do that, this is where the fun part comes in my opinion. When I do that, these x plus 4s will cancel, and I am left with a 5 and an x. On the denominator, or the bottom denominator, I'm going to look at each fraction individually. The x plus 4s will cancel here, and I'm just left with 1x. But the x's will cancel here, and I'm left with 2x plus 4. So essentially what I did is I took this fraction and I distributed it to both fractions, like the left and the right. The x plus 4s canceled. Let me use maybe different colors. The x plus 4s canceled here, and I was left with a 1 and an x. But then on this fraction, the x's canceled, and I was left with 2 and x plus 4. Does that kind of make sense? So you're just distributing that. From there, you're just going to simplify the fraction that you have left. So there's nothing I can do to the top. Claire, do you have a question?
Yeah. Where did the 1 for the x with the 1 come from?
This fraction right here on the left. So this one right here. When I took this x plus 4 and I distributed it to that fraction, the x plus 4s canceled because I had one on the top and on the bottom. So I was only left with a 1 and an x. From there, I'm going to simplify. So nothing I can do to the top. On the bottom, I can distribute. So I've got x plus 2x plus 8. And that leaves me with 5x over 3x plus 8. And then there's nothing I can do from there. Number 19, so now all of my denominators are numbers, so that makes life kind of fun. I want to get rid of all the numbers. So what would be the least common multiple? Like what number is going to cancel all the denominators? 30. So I'm going to multiply by 30 over 30. And think about distributing that 30 to each fraction. So if I take 30 and I divide it by 6, what is left over? 5. So I have 5x. Because imagine, I'm going to just show you like the long way, but I don't write it like this. essentially what is happening is I'm taking 30x over 6 minus 30x over 3 over 30x over 5 minus 30 times 7 over 10. So that's essentially what's happening is I'm distributing 30 to every single fraction. Then this, you told me, reduces to 5x minus 30 over 3 reduces to what? 10x. Oh, it's a plus. 30 over 5 reduces to 6x. And then here we've got 30 times 7 over 10. Do not multiply the 30 times 7 out. I mean, you could, I guess, but I'm going to reduce the 30 over 10 first to be what? 3. Yep, 3 over 1. And 3 times 7 is 21. From there, I can simplify the top to be what? Just 15x, and then 6x minus 21. And that is all that I can do. Okay, so I want you to try number 20. Here are my denominators, x plus 5, x minus 3, and x plus 5. So the least common multiple was x minus 3, x plus 5. Yes?
So you put the x minus 3 to the top for 30. Or like how do you...
So on the top, like if I'm just looking at the numerator right here, this part, imagine writing 3, like this is kind of the long way, but imagine writing 3 x minus 3 x plus 5 over x plus 5. That's essentially what you're doing. So you're putting the x minus 3 x plus 5 on the numerator of each fraction.
So then it'd be like,
And then these cancel, so this is what I'm left over with.
so it'd be like 2x, x minus 3, and then x plus 5.
Mm-hmm. And then the x minus 3's cancel, so I'm just left with 2x plus 5. And then on the second fraction, the x plus 5's cancel, so I'm just left with x minus 3. If you need to write it all out and then cancel, that is fine too. This is just kind of a shortcut way. But either way works. And then once you distribute the 2 and simplify, you're left with 3x minus 9, 3x plus 7. Can the 3x's cancel? No. A puppy would die. The homework for this is the complex fractions practice. Jamie, what page is that on? 167. So on the back of that page, it's kind of like an activity. And you shade, so you get to kind of check your answers and see if they're there, because you're going to shade in the answer, and you're going to be left with one appliance.
So all the answers here
Are on the back, and then there's going to be one on the back that's not there. So there will be one that is unshaded. And the one that's currently shaded right now, what appliance is that? The stove. The stove is the answer to number 1. So when you do number 1, you should get the answer to the stove.
they already did it for you.
Oh, they did it for you? Oh, they did it for you, so you don't even have to do number 1. Makes life easy. So just 2 through whatever for that.